Number 1. The exciting current of an electromagnet is rated at 12 ampere. When connected across a 122 volt source, the current is 14 ampere. Okay. Determine the ohms in a resistor which must be connected in series to limit the current to A. Rated value, B. 9 ampere. Okay, our first step is to read and understand the problem. Okay, let's draw the circuit diagram. If we have a circuit diagram, it means that our circuit have a source, an electromotive force E, and there will be a current flowing in the circuit. Of course, the circuit have a resistance. We have a resistance. These two, we have a two resistance. So, the first is we have a rated. What is the difference between rated and the actual? It is the rating of your resistor, which is 12 ampere. Now, it is connected to the actual voltage of 122 and a current of 14 ampere. So our rated value here will have a resistance value, but the question is determine the ohms, the resistance, the ohms in a resistor to which must be connected in series. This is the series, in series to limit the current. We all know that in Ohm's law, the greater the value of our resistance, the slower the flow of electron. So the resistance is responsible of limiting the flow of the current in your circuit. Okay, so in this type of problem, we have the rated value and the actual value. Let's start with our actual value of current, which is 14 ampere. So at 14 ampere, what is the value of our resistance at 14 ampere? What is the value of our R at 14 ampere? So we'll use the formula, our formula Ohm's law. I is equal to E over R. We transpose R, so the value of your R is equal to voltage over the current. Okay? So the value of your R is equal to E over I. E over I. So we're going to use the rated or the actual value. So we have, based on our problem, we have a 122 volt source. Okay, so that is 122 volts all over our rated current or the actual current. The actual current flowing. So that is 14 ampere. So, okay, so using your calculator, we have 122 all over 14 equal to 61 over 7. Ohms. Okay, so we have the value. Now that we determine the value of our resistance, we need to determine the amount, the value of our series resistor in order to limit our 14 ampere current. So now, of course, what is the value of our rated? So we'll start our rated value. Okay, so R at rated at 12 ampere, which is our rated value. The value of R is what? That is still our Ohm's law over I. That is 122 volts all over the rated value of your current, that is 12 ampere. So this is equal to over 12, that is equal to 61 over 6. That is 61 over 6 ohms. So therefore, analyzing this problem, it means that the value of our series to be series with our resistance here, the value of R to be series with our resistor, that is the difference between your rated and the actual value here. So that is equal to your, at your rated, that is 61 over 6 minus the actual resistance, that is 61 over 7. So what is the result? So 61 over 6 minus 61 over 7 equals to 61 over 42. Okay, so that is 61 over 42, or what is the value in decimal? 1.452380,952 ohms. Okay, so let's discuss this value first. So it means that our rated value at 12 ampere, we have a resistance of 61 over 6 here. We have a 61 over 6 ampere, and our voltage here is 122, and our current flowing here is 12 ampere. So of course, in this condition, if the resistance is not yet stalled, it will flow, right? It will flow in a conventional manner. But since our circuit is connected to the actual source, which is 14 ampere, the question is, what is the value of your RS to limit the 14 ampere flow, right? So that is the difference. So you need to get the resistance here at R14 and the rated value of your current. So the difference, so we have a 1.45 ohms here to limit the flow of your 14 ampere. So that is the statement of the problem says. What is the value of our resistance to be connected to our rated resistance in order to limit the actual flow of current at rated ampere, which is 12 ampere, with a source of 122 volts. Okay, I hope our first problem is clear. So let's continue solving at rated at 9 ampere. So okay, at 9 ampere, so at 9 ampere, okay, so our R is equal to E over I. Our voltage is still the same, 122 volts, and our current is 9 ampere. So using your calculator, 122 over 9 still is 122 over 9. 122 over 9 ohms. Okay, so the same process, your RS, the value of your resistance to be series is equal to the value of your current at 9 ampere. So that is not 9 ampere, not 19. So 9 ampere. So which is, what is the value? That is 122. 122 over 9 minus the value of your actual resistance at 14 ampere, the actual current, which is 61 over 7. That is 61 over 7. So using our calculator, okay, so that is 122 over 9 minus the R current, and that is 61 over 7 equal to 305 over 63, or what is the value? That is 4.841269841 ohms. Okay, let's discuss the problem. Okay, we have a 122 volts. The circuit is at rated current. We have the two value rated current. We have 12 and 9. So when a rated current is at 12 ampere, what is the value of your resistor? Of course, it changes with the given value of your actual current. So when our rated circuit 12 ampere is subject to your actual current, which is 14 ampere, you determine the value of resistance. Okay, so we use our source, 122 volts over the actual current, that is 14, we get 61 over 7. Now that we have 61 over 7, of course, we need to get the value, the rated resistance, which is your rated voltage 122 and your rated current. So 122 over 12, that is 61 over 7. The difference of your rated and the actual current is your 1.45. This is 1.45 ohms. Same process with our letter B. The rated current changes to 9 ampere, but still the actual current is 14 ampere. So we need to determine the value of our resistance at rated first. So that is 122 volts, our source. I mean the rated voltage and the rated current. So the difference is equal to 122 over 9 ohms. So that is our rated resistance. Now, we need to determine the value of our series resistance. So that is the difference between your rated minus the actual, which is the 14 ampere. So 122 over 9 minus 61 over 7 is equal to 305 over 63, or that is 4.84 ohms. Okay, so I hope the problem is clear. Thank you everyone and have a nice day.